Lesson 315, Area and Volume Ratios, Part 2. Please do not forget to give me your course and section number with all communication. I promise you it helps me help you faster. Objectives for this lesson: find and use ratios between volumes of similar solids, and use ratios for volumes and weights to find missing dimensions and measures. The key term that we're going to be using in this lesson is solids that have the same shape and proportional corresponding dimensions. Here are some of the volume formulas that we are accustomed to now that we learned in Unit 2. The volume of a prism is just the base, which is the volume of the area of the base times the height of the prism. We've got the volume of a cylinder, and capital B is always the area of the base of the cylinder, of the prism or cylinder or pyramid or cone. Okay, so what they did here was they plugged in pi r squared, which is the area of a circle. They plugged that in for B, so it'd be easier for you to see what the formula is going to look like. And then down here for the pyramid, you've got the volume equals 1/3 of the base times height. And then the volume of cone is the same way, 1/3 multiplied by the base times the height. And there again, the base is a circle, so they plugged in pi r squared. Also, remember when we were studying changing the attributes, and we went over this when we were studying the area in the last lesson. I'm going to take the volume of the new solid. It's going to equal the volume of the original solid multiplied by the multiplier, and notice this right here, cubed, because volume is always cubed. Okay? Like similar polygons, similar solids have the same shape, and all of the corresponding dimensions are proportional. So here you have two similar rectangular prisms, and I always look at the smallest numbers. If you look on the smallest rectangle, you're going to see that its height right here is 1 centimeter. And if you look over here on the larger rectangular prism, you see that height is 3. So that means that their scale factor is going to be 1/3, which is what they came up with right down here. But you'll notice they used the length 2/6 and then reduced it to 1/3. Okay, that's how they did that. And then right here they took the smaller 4/3 over 4, and you flip that around and you do some multiplying and all that, and then you're still going to get 1/3. And all this business of reducing is exactly why I look for the smallest numbers, so I don't have to worry about reducing. I try to get out of that if I can. Okay, what's happening here, it says the volume ratios of similar figures, and remember I told you we're going to take the new, which equals the original, times the multiplier cubed. There we go, had a little blip. Okay, so the other thing that I want you to look at here is that the multiplier that the formula refers to is the scale factor of a dilation. So you can replace the term multiplier with scale factor in the formula. And this is just like we did with the area in the last lesson. So I'm going to replace that new with V2 right here, the original with V1, and I replaced the word multiplier with scale factor. And this is what it's going to look like after we do that. So now we're going to let T replace the words scale factor, because remember we're going to call the scale factor, we're just going to call it T. So look how we have shortened up this formula, because we went from this V new equals V original times the multiplier cubed. We went from that to this. Now, what we're going to do is we're going to get that T cubed all by itself. And in order to do that, we're going to divide both sides of the equation by V1. Remember, that's how you get the variable alone. And so it's going to look like this. So if you divide each side of the equation by V1, you have a ratio of the volumes. We've now developed a formula for the volume of ratios. Sorry about that. I don't want that there. I don't know if y'all saw that or not, but it was poking up there. And we have also found that the ratio of the volumes of similar figures is equal to the cube of the scale factor. So in other words, if we know the volumes, we can put them on top of each other like this, put V2 over V1, and it's going to equal the scale factor cubed. So when we find the cube of the scale factor, then we know what the scale factor is. Okay? So let's go on and see what else we're going to get to do. Oh, we're going to jump right into some examples. So this is where Miss Poor gets to do some writing. It says, if the radius of a sphere is multiplied by a scale factor of 5, by what scale factor does the volume of the sphere change? Well, you say, well, duh, Miss Poor, it says it's a scale factor of 5, so that's how much it's going to change. But you've got to remember that scale factor for volume is cubed. So what you've got to do is you've got to take the scale factor and you've got to cube it. All right? And so in order to cube it, I'm looking to see here right quick how I can maybe change the amount of ink I got up here, because that's a little too thick for me. So that my scale factor, oh, that was too much, is 5, and I'm going to cube it, and so 5 cubed is going to give me 125. So I can write out here the volume of the sphere changes by a scale factor of 125. And there's the official answer, as always. Okay, this says prism A is similar to prism B. Find the volume of prism B if the volume of prism A is 1,120 cubic inches. So let's see what we've got here. We're going to set it up like this. We're going to say the volume A is going to equal 1,120 inches cubed. And I got that information right here. Then the volume for B is going to be, we don't know, because that's what we're trying to find out, right? And then we're going to let our scale factor, they told us the scale factor, didn't they? No, they didn't. But we can figure it out. Here's our scale factor. What we're going to do is we're going to come over here. We're going to use these numbers to determine what our scale factor is. Okay? And remember that we set it up like this. We put the new image in the, I'm going to get this out in a minute. We put the new image in the numerator and the original image in the denominator. Okay? So our scale factor is going to look like this. 7 over 14. You know, I told you I always go for the smallest numbers. Well, those are the only numbers they gave me. So I can reduce 7 over 14 to 1/2. So that's going to be our scale factor in this problem. Now then, we came up with that volume ratio formula earlier. So this was what we've come up with, that we take VB over VA. Actually, the formula said V2 over V1, but they're using A and B here, and we want to make it as the least confusing as possible. And that was going to equal T cubed. So when I fill in all the numbers that I know, because you think about this, I think this is a highlighter. I'm using this program for the first time. So I know that amount, and I know that amount. Okay? So I can go in and plug this plug and chug. That's what I'm doing. And VA is 1120, and I know T is 1 over 2, and I'm going to tell you, always put parentheses around it like that. And the reason we do that is so that way we're telling people, hey, we're cubing the whole fraction. We're not just going to cube the numerator. We're not just going to cube the denominator. We're going to cube it all. So when I do cube it, we're going to take care of that first. 1 cubed is 1, and 2 cubed is 8. Now I have set this up to where all I have to do is remember cross multiplication. That's all I got to do now. So I'm going to have 8 VB, and then 1120 times 1. You hear me call that 1120. That was 1120. Now remember, VB is kind of like a variable right now, an X, and we want to get it all by itself, because that's what we're trying to find out here, is what is the volume of prism B. So I'm going to divide both sides by 8, and 1120 divided by 8 is going to give me 140. So there we go. So the volume of prism B equals 140 inches cubed. See how easy that was? Y'all can do this. I feel it. And there's the official answer. They didn't have any weird looking things that I needed to show you, but it was still a good problem to work through. Here, in this problem, we have cylinder D is similar to cylinder E. The volume of cylinder D is 1,280 pi cubic centimeters, and the volume of cylinder E, I guess we ought to underline that, cylinder E is 540 pi cubic centimeters. Oh, look here, they want us to find the scale factor that would reduce cylinder D to the size of cylinder E. So we're still going to be using that volume ratios formula that we came up with earlier. And this is what it looked like. Just a reminder. Oh, this is D and E. I mean E and D, whoever. Oh, this doesn't have a handy dandy undoer, so let me get my little eraser. Oh, I like that. Okay, so E over D, and then T cubed. So I'm going to plug in everything I know. They told me that the volume of cylinder D was 1,280 pi. They told me the volume of, oh, I did it backwards. I'm glad I caught myself before I got too far. Let's do E because it's in the numerator. It was 540 pi. Now I can put D in there. 1,280 pi. And that's going to equal T cubed. Well, let's see what can happen. We can reduce this. If you'll notice, I mean, you could reduce it by 2, but the easiest way to do this is, I'm going to show you how to do it in your calculator. Okay, you can see my calculator up here. I'm going to move it over here for just a second so I can see the fraction and y'all can see the calculator. I'm going to enter in, I'm not really worried about the pi because the pi is actually reduced to 1. So all I'm going to enter in my calculator right now, well, you know what? Let me go ahead and put pi in anyway. Why not? Okay, 540 pi divided by 1280, or whoops, 1280 pi. And then I'm going to push math. And notice number 1 says fraction or frac. That means fraction. I'm going to push enter. And I'm going to push it twice. That gives me what the decimal value looks like, and that's not what I wanted. So let me enter in the 540 divided by 1280. I'm going to push math, enter, enter. Oh, there we go. I get 27 over 64. So you can't put the pi in there. And the reason is because pi goes on forever and ever and ever. And if you try to put it in there in the calculator, it's going to multiply by that whole forever number of pi. So that's why we couldn't do that. But anyway, you see what we got here. Our fraction is 27 over 64. So let me come back to my problem. Okay, I'm not going to do anything with pi right now. I'm going to leave it there. I think it was over 64 equals t cubed. Now, let me show you about the pi now. Pi, these reduce to 1 and they disappear. So now I'm just left with 27 over 64, correct? I hope you agree. So now what I'm going to do is I'm going to cube everything. Oops, got to write 64 in there, Miss Poor. And the reason I'm cubing everything is because I want that t all by itself. Because when it's all by itself, then I'll know what my scale factor is. Well, if you use your calculator, and we can do that too, to figure out what 27 and 64 cubed are, all you have to do is type in 2, oh, I got excited. Let me see. See number 4 says cube. So I'm going to say 4, and then I'm going to type in 27, and I'm going to hit enter. So 27 cubed is 3. Now let me do that, number 4, for 64. And hit enter. And that is 4. So 3 and 4. So I can come over here and say 3 over 4. And then the cube root of t cubed is going to give you t. So that's going to be my scale factor for that cylinder. See how easy that was, especially in the calculator. Calculator made it super easy. And there's how they worked it out officially. Okay, cone S is similar to cone T. The volume of cone S is 160 pi over 3 cubic centimeters, and the volume of cone T is 180 pi cubic centimeters. What is the height of cone S if the height of cone T is 15 centimeters? So let's check this out. We're still going to use that same formula, that volume ratio, and here's how we're going to set it up. And I'm trying to write smaller. The volume of cone S is 160 pi over 3 cubed. And we don't need parentheses here, okay? We don't need parentheses there. And the volume of cone T is going to give me 180 pi centimeters cubed. And I know now why I didn't need parentheses there, because I forgot to write out the word centimeter. Not the whole word, just, there we go. There we go, now it's perfect. Miss Poor gets there eventually. And then the height of HS, we don't know. The height of cone T, they told me, is 15 centimeters. There we go. So now we get to use our fancy formula. We're going to put VT over VS, and that's going to equal T cubed. So we're going to plug and chug now. Now the problem is here, for VT, that's pretty easy. That's 180 pi. But look at what I've got for the volume of cone S. Ugh, a fraction and a fraction. Yuck-a-doo. And then over here, for my scale factor, I'm going to plug in HT over HS cubed. All right. And then for HT, I'm going to go ahead and erase that because I can. But I wanted to put it there so you could see it, and I'm going to replace it with 15. Okay, now then, cross multiplying. Ugh, this side looks like it'll be all right. Pretty easy to handle. 180 pi, and then I've got HS. Oh, but I got to cross multiply this way. Now remember, I'm going to do some hen scratch over here. This is what I call doing my scratch work, hen scratch. 160 pi over 3, I'm going to multiply that by 15 over 1. Now remember, when you multiply fractions, you multiply the numerators and you multiply the denominators. So 160 pi times 15, and I'm making sure to see if I do it in pi. Yeah, I do. Making sure, because I don't want to get y'all confused. Okay, I'm going to back up here a little bit. I kind of went crazy with my cross multiplying before I should have. Let's get rid of that ugly fraction before we go all wackadoodle trying to cross multiply. I'm going to go ahead and plug in that information again that I had. 180 pi over 160 pi divided by 3 equals, and remember, I'm going to replace this T cubed. I'm replacing it with HT over HS cubed. So for HT, I'm going to plug in 15, and I still have my HS. And remember, H is just standing for the height. Whoa! I was trying to make a parentheses. There, I better do it a little slower. I think I did it too fast and it changed my slides. Okay, now what we're going to do in one fatal swoop is I'm going to reduce this fraction over here. Well, you know what, let me highlight it. I'm going to reduce this fraction, and at the same time I'm going to cube that. So look what happens here. If I'm going to reduce that 180 pi over 160 pi divided by 3, you remember when you work fractions, I've got 180 pi, and I'm going to multiply it by the reciprocal of the denominator. Well, when I do that, my pi's go away. They reduce to 1. I get to cancel those out. So I'm left with 180 times 3 equals 540 over 160. Well, when I divide 540 by 160, I get 3.375. However, I want that in a fraction form. And in order to get that in a fraction, I can use my handy dandy calculator. Now watch this. Let me clear this. If I put in there 540, let me move my calculator over so you can see what I'm doing. I got this 540 divided by 160 gives me that. So I can push math enter and it'll show me what it looks like as a fraction, which is 27 over 8. So let me write that over here. 27 over 8. So I've reduced this fraction, 27 over 8 equals, and then 15 cubed is going to give me 3,375 over the HS. And you know what? That HS is still cubed, so I have to put that there. Now Miss Poor is ready to cross multiply and divide. Oh no, she's not. Yes, she is. Don't let me confuse you anymore, because I'm confusing myself. Okay, so 27 times HS cubed, there we got it, the height of cone S cubed, equals 27,000 when I multiply 8 times 3,375. Now I'm going to divide both sides by 27 so I can get that H cubed all by itself. And I'm going to finish my problem up here. So I've got HS cubed equals 1,000. Now I'm going to come in here and I'm going to get the square, or the cube root, excuse me, not square, the cube root of each side. So when I do that, I end up with the HS, and 1,000, the cube root of 1,000 is 10. So that means that the height of cone S equals 10. And here's the official, but I just wanted, the reason I did this problem was because I wanted to show you how they got from this business to here. And that's why I said, whoa, I started cross multiplying too fast, because then you missed it. Okay, summary. You should, never mind, you shouldn't be able to do anything. It says the ratio of volumes of two similar solids is equal to the cube of the scale factor, and that's what we did, and you should be able to figure that out now. And this is what's going on. You should be viewing the video and then going to your LMS and completing the student guide, going over the lesson and the reference guide. Complete problems 17 through 25 odd in your problem set. And please contact me or attend TOGA if you have any questions before you complete the 315 quiz. And that's going to be it for lesson 315. Thanks for listening.